Hey everyone, it's time for 10.3 polar coordinates. We're done with parametric equations and the calculus behind them. Moving on to polar. So here in 10.3, we're going to introduce what polar coordinates are, the polar coordinate system from the ground up. And then we are going to look at derivatives here in 10.3. Turns out the conversation for integrals with polar is a lengthy one, so we save all that for 10.4. Okay, so what are these things? What are polar coordinates? Okay, so this is a brand new way to think of a location with a whole new coordinate system. So up until now, guessing the only thing you've seen, if you were like me when you took Calc 2, up until then, all I'd ever seen was the XY plane. But here we go. We're going to learn a whole new way to talk about coordinates, and a really cool one. And I mean, you'll see the application right away. So here's how the polar coordinate system looks. So hopefully you have this handout here that I posted just above the link to the lecture. So if you don't, at least download it. If you can't print it, ideally you can print it so you kind of work along with me here. Maybe just follow along. I think you'll be fine with that. But if you can at least kind of be looking at it on your own at the same time. Okay, by the way, please ignore this big blob. I think the last time I was teaching, I probably touched it with the dry erase marker, and so that's not anything that shouldn't be there. So how does this whole thing work? Okay, so we're going to plot all of these points, but they're defined in this very interesting way. The first number you see is the radius. So we're going to start from the center and we're going to move out however many units we need to get that radius. This tells us the angle. So we have angle 0 here, the positive x-axis, and then it rotates around. Okay? So this first point, 4 pi over 6, we're going to say, okay, I need to go out 4, 1, 2, 3, 4, and then I need to rotate pi over 6, and I land right here. So that is the point 4 comma pi over 6. I went out 4, 1, 2, 3, 4, and then I rotated pi over 6. So that's that one. Okay, the next one. 2, 5 pi over 6. Well, same idea. You need to locate the angle and the radius. Sometimes people like to move out the radius and then rotate, but probably more common, you just identify where that angle is, and then, okay, I need to move out 2 in that direction. So there's 5 pi over 6, so I'll move out 2. Radius of 2. Radius, angle. And we got that one. Hey, let's throw some negatives in, and then we'll do some zeros to finish off. Okay, how about 5 negative pi over 2? Ooh, interesting. So let's find, well, where's negative pi over 2? I have to rotate down, right? So if there's pi over 2, negative pi over 2 means I rotate this way, and then I go out 5. 1, 2, 3, 4, 5, and I'm all the way down here. So it's the same angle as 3 pi over 2. I know it's too blurry on the video here, but on your own paper, at 3 pi over 2 down there, right, that's the same as negative pi over 2, right? So I rotate negative 90 degrees, negative pi over 2, and then go out 5 units. And we got that one. How about we put the negative on the r? Now this gets way more interesting. Negative angle, we all get that. We've worked with plenty of negative angles up until this point. Goes back to trig, right? No big deal. What if the radius is negative? Okay, here's what you do. Find the angle, this one pi over 4, but then instead of counting out positive, you count backwards. So starting there, you go back. We're thinking of it in this direction towards pi over 4, but we're gonna fall away in the backwards. We're gonna land right here. So that is negative 3 pi over 4, where we're like facing pi over 4, but then we end up taking 3 steps back. And we end up right there. And at this point you realize that, hey, isn't that the same point as, what is that, 5 pi over 4 with positive 3 radius? And yes, that is also, you could describe this location as 3, 5 pi over 4. Positive 3, positive 5 pi over 4. Any of these locations you could describe with a negative radius if you took the opposite angle, right? Even this one, you could think of it as, what, 11 pi over 6 with r is negative 2. So because we're dealing with angles now, we can have multiple ways to describe the same location. But that negative radius, that's going to come up later when we talk about graphing. So that's big, the negative radius. Like you're facing that way, but you're walking back. Okay, lastly, what about some zeros? 1, 0. Okay, so the radius is 1, but the angle is 0. Okay, no problem. Angle 0, radius 1. I move one direction at an angle of 0. No problem. The angle being 0, just like negative, really nothing new for us. What if the radius is 0? 0 pi over 6. Okay, so here's pi over 6. So I'm gonna, it's like I'm standing there and I'm looking at pi over 6, but then I'm not walking forward at all. I'm just gonna sit right there, and it's actually the point right there at the center. So the point right there at the center, well, that's, you could put any angle you want. If the radius is 0, you're gonna be sitting right there. So there they are. How many do we have? 6 of them. 1, 2, 3, 4, 5, 6. Yeah, we got them all. Okay, you also see at the bottom there, after plotting the points on the same polar axes, graph each polar curve. And we picked the simplest things we can. R equals 2, theta equals pi over 3. What would that look like? So those are going to be full-on curves. Let's start with r equals 2. So r equals 2 means that that's the radius for any angle. Your radius is 2. You might even say for any. Let's make it even more clear. For every angle. At every angle you consider, the radius is always 2. So what does that mean? I'm going to go out 2, and then I'm going to end up drawing this circle, because for every single possible angle, I get radius of 2. So I've got this radius of 2 just circles back around, and that is the graph of r equals 2. If you're wondering, like, what's the usefulness of polar coordinates? Well, their ordered pairs are kind of interesting, but it's all about rotation, right? Think of the center as like the center of gravity. So this would be like something in orbit. Hey, your radius is 2. You've got an orbit of 2. You're 2 units away from the center of gravity, and you're just going to move along. Okay. How about theta equals 2 pi over 3? That means for every radius, your angle is 2 pi over 3. So I'm here. So I'm going to look at 2 pi over 3. That's this direction, right? And every radius is considered. So I'm just going to, it's just this line, just this angled line coming out of the center, going out. And not just the positive radii either, but I have to consider negative radii, so I need to go backwards too. And I end up with this line. So out to pi over 3, but then the negative radius is negative radii as well in the opposite direction. So this ends up being this slanted line pointing at pi over 3. I mean, what's happening there? If this is like the center of gravity, it's like I'm shooting away at this angle, or I might shoot back this way at the same angle in the opposite direction. Hey, I thought that was a lot of fun. Just getting used to this. Getting our feet wet. Okay. Let's now get serious. Let's introduce officially 10.3 right now, and we'll just kind of chat about polar coordinates. You know what? This is going to make this first video a bit lengthy. Let's stop here. We're going to do this in the next video. I think we did the intro well. Took about 10 minutes. Come back for the next video for this guy.